Hello guys, I hope you are doing well. Today we are discussing asymptotic notations and growth of functions. Growth of function, or you can say growth of algorithm. These both topics are very important and they provide baseline for the design and analysis of algorithm. It's very important for the design and analysis of algorithm. In asymptotic notation, we will talk about three asymptotic notation which are very important, and in growth of function we will discuss how the algorithm or how the function or formula grows upon the inputs, upon the different inputs of a number of inputs. So first I will discuss growth of function, which is very important, and because growth of function is more important than asymptotic notation, because we should know how the algorithm will grow, how the function will grow upon the different inputs and set of inputs. So it's very important. So here you can see growth of function, example of growth of functions like log n, n log n, and n square, then exponential, and we can see the factorials. These are the different functions react on different inputs. On x-axis we can see different inputs, and on y side we can see the output of these particular algorithms, of these particular functions. So it means that the function should have inputs which are in ascending order, like you can see here 2, 3, 4, 5, 6 and 8, because here we are discussing the time complexity. So for the time complexity we should have the ascending order. We are talking about the time complexity of algorithm. We must have the ascending order of different items, or the set of items. So it will like if we give input to the algorithm, to the formula, to the function, it will process that input, and how much time it takes to process that particular input. This is very important, and we are going to calculate the time complexity, because the time complexity is very important for the researcher and for the programmer. They can directly understand that how much time that particular algorithm will take, because nowadays the time is very important. If we discuss the deep learning and machine learning and different application of deep learning and machine learning, then we can understand the time complexity is very important. Like if, for example, if we are talking about the driverless car, the georeferencing, remote sensing, so time complexity is very important. So the next one is asymptotic notation. Asymptotic notation is just a notation. Most of the students are confused between the two different concepts. Like one is the worst case, best case, and average case. These are the one concept. And on the other side we have the upper bound, lower bound, and average bound. Most of the students then mix their two concepts. Actually they are different from each other. These two concepts are totally different from each other. Let me give you an example. The best case, average case, and worst case, it depends on your problem. It depends what you want to achieve, what is important for you. From the algorithm, what you want, which one is best case for you. Like for example, if you have 50,000 rupees and you want to buy Android mobile to use WhatsApp, let's suppose. So you can buy Android mobile and 10,000 rupees also. But I think it will not work for you. It's not a best case for you. So you will buy 50,000 rupees mobile, because it is best case for you, because you want, if you want to have WhatsApp, so definitely you want to have good RAM and good processor also. But if I am talking about the iPhone or some other mobiles whose price is more than 100,000 rupees, so it will not be best case for you. So it will be worst case for you. So the average case, like one is the 10,000 mobile, the other one is 50,000, and the other one, last one is 100,000 mobile. So the 50,000 mobile is best case for you. However, it is average case, but still it's a best case for you. So don't mix the worst case, best case, and average case with the upper bound, lower bound, and average bound. Asymptotic notation is just notations. They don't have any concern about the best case, worst case, and average case. They just only give you the complexity of algorithm, that it will take that much of time. If it's good for you, then it will be best. It will be your best case. If it's not good for you, it will be worst case for you. So it's only concerned with the time complexity. But still, if you can say that, okay, I'm talking about the time complexity. For example, if you are working on a driverless car, so in driverless car, the time complexity and the accuracy both are very important. So in that case, you can say that, okay, the algorithm which takes less time as compared to, like algorithm A take less time as compared to algorithm B, then the B is the best for you. So in that case, you can say it's the best case for me. But it's again depends on your problem nature. So in asymptotic notation, we are discussing three notation which are very important, and that is big O notation, omega notation, and theta notation. Big O is the upper bound, omega is the lower bound, and theta is the average bound. So these three notation, there are few more, but these three notation are very basic and this is very important. And we represent the time complexity in that particular three notations. So here you can see. So in the next video, we will discuss the asymptotic notations, and we will have some example as well. So here I will give you just a general example. Like for example, if you ask me that what is the normal size of a room door, so my answer will be approximately 7. So approximately 7 mean that it means that it can be 7.2, 7.3 somehow, or it can be 6.9, 6.6, 6.8, something like that. So it means that the 7.2 or 7.3 is the upper bound of the existing algorithm, the existing approximate, and 6.96 is the lower bound. So these two are the upper bound and lower bound of the 7. So this is a general example about the upper bound and lower bound. So this is all about the upper bound, lower bound, and average bound. So in the next video, we will have some example on time complexity, and we will discuss in detail. Thank you so much. I hope you have enjoyed today. If you have any question, you are always welcome in the comment section.